In this lesson, we're going to talk about multiplying, dividing, and dealing with powers to the power. So we're going to be multiplying powers with other powers, dividing powers, and in the end we're going to talk about cases where you have to take a power to the power. And it might seem a little weird now, but it should be pretty easy once we get through this. So first I want to talk about multiplying powers with the same base. Now this is very important right here. Very important, because almost everything we talk about here today applies only to powers that have the same base. Now, a quick review of what is a base and what is a power or an exponent. So, for example, here I have 4 different exponential forms, and each of these exponential forms, the large number or the large variable is the base. The little number off to the right upper corner there is the power or the exponent. So when I talk about multiplying powers with the same base, I'm talking about, in this case, the bases being the same, the bases being the same. So here the base is 2 and 2, here the base is a and a. And that's very important, because if you're talking about multiplying and dividing powers with different bases, these rules will not apply to them. So these rules only apply to powers that have the exact same identical base. Alright, so what do we do? Let's take a look at the first example here. We have 2 to the 4th power, and we are multiplying it by 2 to the 2nd power. The first thing you should do is make sure that they have the same base, so that this is actually going to apply, and indeed they do. They both have a base of 2. Then let's go ahead and write them out like you know how to do these. So how can I write 2 to the 4th power? How can I write that out? Someone tell me. Now hopefully someone said take the base 2 and multiply it against itself 4 times, because that's what the exponent tells you to do. So take the base 2 and multiply it against itself 4 times. Alright, next we have a multiplication. Let's put that multiplication in there. And how do I write 2 to the 2nd power? Someone tell me. If you said take the base, which is again 2, and multiply it against itself twice because the exponent's 2, you're also correct. And if you were to do this part by part, that's what it would look like. 2 to the 4th power, 2 times 2 times 2 times 2, times 2 to the 2nd power, 2 times 2. Now, imagine that this was a singular expression. How many times is the base 2 being multiplied here against itself, all in total here, if this was just a singular expression? If you said 6, you would be correct. 1, 2, 3, 4, 5, 6. So if this was a single expression, this would be the base 2 being multiplied against itself 6 times, which in exponential terms would look like this. Correct? It would. Now take a look what happened here. I have an exponent of 6. I have an exponent of 4 and an exponent of 2. How did I get this 6? What can I do to this 4 and 2 to get a 6? If you said add, you're absolutely correct. If you said anything else, I'm sorry, but it's okay. So yes, that's what we're doing. We're adding the powers or the exponents. So in a case where you have the same base, and again, this only works with exponential forms that have the same base, but in a case where you do have the same base, you can take the exponents, and in the case of multiplication, add the exponents. Not multiply, add the exponents. You leave the base alone, the base stays as it is, and you simply add the exponents. Let's take a look here. This is the other example. So here we have a to the third power. How can I write down a to the third power? How can I write it out? If you said take a and multiply it against itself 3 times, you're correct, as I know you are. What about a to the second power? If you said take a and multiply it against itself twice, you're also correct. And we had a multiplication between them. In exponential form, how many times am I multiplying the base a against itself here, if this was a singular expression? If you said 5 times, you're correct, which would mean this entire thing can be written as a to the 5th power. So what did I do? To get to 5, I added 3 plus 2, 5. So in the cases where you do have the very same base, has to be identical base, you can simply add the exponents. As simple as that. Not multiply. I know you're multiplying the 2 exponential forms, but if you multiply 2 exponential forms and they have the same base, you add the powers or the exponents. All right, let's see what this actually looks like in a case of a few examples. And we're back. So here we have 6 to the 6th power times 6 to the 3rd power. I have a question for you. Are the bases in these 2 exponential forms the same? Yes, they are. They're both 6. So what can I do to the exponents in this multiplication problem that has 2 exponential forms with the same base? If you said add the exponents, I would wholeheartedly agree with you. So let's go ahead and do that. The base stays the same. I do not do anything to the base. I simply add my 2 exponents, which in this case are 6 plus 3. And can someone tell me what that is? It's very simple. 9. So 6 to the 9th power is what that comes out to be. And it's as simple as that. That's really simple, right? So simple that I'm going to let you try the next one on your own. So go ahead. First of all, any questions on that one? If not, go ahead and try this next one on your own. I'll give you a minute here, work it out, and then we'll see what you get. I'm going to pause this. Okay, so what do you think we should do here? What do you think we should do to the powers here? If you said add the powers and leave the base alone, you're absolutely correct. You leave the base alone if it's the same base, and you add the powers. As such. And that's not so bad. What's 2 plus 3? That's 5. And that's the answer. It really can't get any easier than this. Alright, let's try one more here, just to be safe. And again, I'm going to let you work this out on your own. Alright, try this one on your own. Do be careful of that negative, but treat it just like any other negative number. So go ahead, I'll pause this. Okay, so do they have the same base? They do, which means we can use what we learned here. We leave the base alone. And what would we do to the 2 powers, since it's multiplication with the same base? What do we do to the 2 powers? Well, we add them. So we're going to add a -5 and a 7. We can do that. We've added integers with different signs before. This is nothing new at all. So can someone tell me what's negative 5 plus 7? If you said just 2, positive 2, you're correct. And that's our answer. As simple as that. So does anyone have any questions with the multiplying of powers that have the same base and how to work these out? All right, let's go ahead and move on and talk about division now. All right, so now we're going to talk about dividing powers with the same base. Rules are pretty similar, and just like multiplication and division are cousin operations or sister operations, they're similar in many ways. Multiplication and division are also tied together. So you can probably guess here, but I'll go through the motions. But if we multiplied two bases with the same power, we added the exponents. If we're going to divide two exponential forms with the same base, guess what we're going to do to the exponents? If you guessed subtraction, you're correct. But let's see how that exactly works, because I don't just like showing you the shortcut, I like to show you how it works. Alright here, so how can I write just a 3 to the 6th power? How can I write that out? If you said take the base 3, multiply it against itself 6 times, you would be correct, as I know you are. Which would be 3 times 3 times 3 times 3 times 3 times 3. All right, I'm going to do our division line here. Not as straight as it could be, but it's okay. What about 3 to the 2nd power? How can we write that out? If you said 3 times 3, you're correct. Take the base, multiply it against itself twice. Now, do you remember way back when I told you that you can simplify the same number if you found it in the numerator and the denominator? You know, cancel time? Well, you can do that there, or you can do this right here. 3 with 3, 3 with 3. So what are you left with in the numerator? How many 3's are you left with in the numerator? 1, 2, 3, 4. 4 of them. Do you have any 3's left in the denominator? No, the denominator is gone. So all you're left with is 3 times 3 times 3 times 3. And how can I write this as an exponential form? If you said 3 to the 4th power, because I have the base 3 being multiplied against itself 4 times, you would be correct. And that's Discovery Club. Alright, so 6, 2, and I got a 4 out of it. So what did I do to the powers, you think? I kind of already spoiled it. So I subtracted. So when you do have powers with the same base, and I have powers, and I am dividing, the rule is subtract the powers, or subtract the exponents. Leave the base alone and subtract the exponents. But let's look at another one just as an example. So here I have x to the 5th power. So how can I write out an x to the 5th power? Someone tell me. If you said take x and multiply it against itself 5 times, you would be absolutely correct. What about x to the 3rd power? If you said take x and multiply it against itself 3 times, you're also correct. And now, I can cancel the same variable from top and bottom, can't I? Gone, gone, gone with these 3. So, is there anything left on the bottom? No. What's left on the top? these two, x times x, which is x squared. So if we were to apply our shortcut, if we were to subtract the exponents, 5 minus 3 is indeed 2. So the shortcut would be, if you're dividing powers with the same base, simply subtract the exponents. But this is why that works. This is why the shortcut works mathematically. This is why I'm showing it to you. And no, you don't have to use the long way on the quiz or on the homework. You can if you really wanted to. It can get painful with larger values. But just for your understanding. Now let's practice. Questions? Practice. Let's start at the very top. We have 7 to the 5th power divided by 7 to the 3rd power. My first question to you, do these exponential forms have the same base? And what is that base? If you said yes, and that the base is 7, once again, I would agree with you. If you said no, then yeah, we're going to go with yes. If you have the same base, and you have two exponential forms and they're being subtracted, what's the rule when it comes to dividing the two exponential forms? What do we do to the exponents? If you said subtract them, you're absolutely correct, and I will agree with you. So 5 minus 3. And what is 5 minus 3? 2, says everyone, which is correct. And that's our answer. And that's as simple as what we did with multiplication. So simple, in fact, that I'm going to have you work on the next problem on your own. So I'm going to give you 40 seconds or so. Work it out on your own. And then we'll see if you got it right. So go ahead, I'll pause this. Okay, so do these two have the same base? They do. They have the same base. And the rule is, if they have the same base, I take the powers, or the exponents, and I subtract them. 10 minus 9. Which, of course, yields 10 minus 9 is 1. And as we learned in the previous section, anything to the first power is the number itself, or in this case the variable itself, so just x. And that's the answer to that. Super simple? Yes, indeed. Try the last one on your own. I'll give you 45 seconds. I'll pause this. Go ahead. Once again, the question is, do these have the same base? And yes, they do. 9 for both. So write the base, leave the base alone. And what's the rule when it comes to dividing powers with the same base? What do you do to the exponents? You subtract. So I'm going to subtract 12 minus a negative 5. Hopefully everyone caught that little trick that I put in there. So 12 minus a negative 5. It's not 12 minus 5 because that would mean this 5 was positive to begin with. It's not. Alright. That is the same as 9 12 plus 5. Because negative and negative turns into positive, which is the same as 9 to the 17th power. Now, you don't have to work that out, thankfully, because there would be a considerably large number. Let's just put it at that and leave that alone. So that's good enough as an answer. Because yes, that would be a very big number that I would not want to do by hand. All right, any questions with that? So the last part deals with taking a power to a different power. So it's power to the power. It's like powerception. It looks kind of weird, right? You have a single base, the same base, but you have two different powers. How does that even work? Well, let's see how that works. How can I write c to the third power? If I were to just ask you to write this out, c to the third power, how would you work that? If you said take c and multiply it against itself 3 times, you would be correct. C times C times C. So the c to the third power is c times c times c. Multiply the base against itself 3 times. And we still have this being taken to the second power itself. So imagine that this is just any base, any regular base. What does the exponent tell you to do with this base? What does the exponent tell you to do with this base? Well, doesn't it tell you to take the base and multiply it against itself twice? It does. So you can do this, right? You can take c times c times c, multiply it against c times c times c. Sure you can, of course you can, why not? And here the parentheses aren't really necessary, so I can drop them. So in the end, what do we end up with? What do we have? That we have c being multiplied against itself 6 times. And can't we write that as this? We can. So how did we get a 6 out of 3 and 2? What operation did we use? If you said multiplication, you're absolutely correct. So, in the case where you have power to the power, one base but 2 exponents, one inside a parenthesis, one outside, you multiply the 2 exponents. This is the only case when you multiply exponents. The other case you were adding, when you had 2 bases and you were multiplying the bases, you added the exponents. In this case, you multiply. Let's practice, and this is going to be a lot better with some practice. So here I have a base 5 to the 4th power taken to the 2nd power. So what can I do in these situations? When I have an exponent taken to a higher power, what can I do to the exponents? If you said multiply them, you're correct. We leave the base alone. And then we take our 2 exponents, 4 and 2, and we simply multiply them. 4 times 2. And what's 4 times 2? 8, of course. And that's the answer. As simple as that, which is pretty simple. So let's do some more practice. All right, take a 40, say you don't need 40 seconds for this. Take 30 seconds and work that one out on your own. Should be pretty simple. Pausing. So you have a power taken to another power. What do you do here? What do you do to the 2 powers? And do you do anything to the base? You don't do anything to the base. And you multiply the 2 powers together. Which of course yields 7 times 10 is 70. have fun writing this out in simplest form. That'd be cruel if I made you do that. Right? Yeah. You're not, okay, you don't have to. All right, questions on that? Seemed simple enough, right? Well, let's try something with a bit of a twist in it, a small little twist. Try this one. Just like before, the base doesn't change. And what do you do with the exponents? If you said multiply them, you're correct. So you take 3 and you multiply it by a -4. Mind your signs. And what's 3 times -4? The base stays. If you said -12, you're correct. And how can I simplify this so it doesn't have a negative exponent? Someone? If you said flip it or take its reciprocal, you're correct. And that would be my final, almost simple answer. Of course, you could simplify that by multiplying 3 against itself 12 times. I'm not going to. You don't have to. Let's try one more, and then we are done for the day. Try that one. I'll give you 30 seconds. Pausing. Okay, so the base, just like always, does not change. What do we do with the exponents? Someone tell me. We multiply them. -8 times a -2. And what does that yield for us? What's -8 times -2? A positive 16. And that's it, because negative times negative is positive. Any questions on any of these problems before I sign off? Thank you.